So, thanks very much for inviting us here today. I'm Charles Duca, Graham Cox. I'm in the minority of one, being a doctor, being a surgeon here in this meeting. And the reason why I'm here, why we're here, is related to actually a strange thing. But before I go into that, Justin, how do you feel? Yes, pretty happy. Good evening. Drink, whatever. But how do you know how you feel? It's a very difficult question to answer, something we're trying to dig into, but quite difficult to fully dig down into. So this is Bethan. She was in a car accident about 8 years ago. Her skull was crushed and both facial nerves were severed at the base of the skull. And she was referred to me about 2 years later, and this was her at that time. She had bilateral facial paralysis. She was able to make a very small movement on one cheek, couldn't close her eyes, couldn't close her lips, to drink or eat, or even kiss a loved one. In a way, she was trapped inside her own face, like Julian Heron's artist. So VR, we're all here about VR, and VR has been described as the machine to generate empathy. It's an incredible immersive technology. But how do you measure how you feel? Obviously, in films and TVs and games, you can ask people questions from these questionnaires, but clearly there must be better ways of measuring emotional responses. How can we measure them? Well, there are a number of ways that emotions can be measured, and they're manifest through responses from the brain to our nervous system. The peripheral nervous system, i.e. that is automatic, the most primitive parts, manifests as an increase in heart rate, changes in skin conductance, manifests as sweating. You'll see that as a change in respiratory function, change in visual attention, but also, importantly, in our facial expressions. And these are very, very primitive responses based on what we feel and see. In terms of facial expressions, obviously the nerves fire off the muscles, which cause change that you can measure on the surface of the camera, but before the surface changes are visible, there are changes in muscle activity, and that's where we come in. So we can measure facial expressions and emotions, but also can measure other parameters as well. So with VR, we can measure where a person's looking, and a number of ways of doing that using mostly gaze tracking. And there's some analytics platforms out there looking at gaze tracking to see where a person looks. But the main problem is that it's only something's happened, i.e. they've looked at it, but not why. What's the background? Why? Is it because they didn't like this thing, or is it because it's a bit strange, a bit odd, a bit confusing? This chap is Paul Ekman, who's one of the leading psychologists in emotion research, and he did some pioneering work back in the 1960s, and he concluded that of all the ways of measuring emotion, the face is the most insightful. It's the richest source of information about human emotions. Obviously, facial expressions are very complicated. There's a three-dimensional array of muscles, nerves, and fibers that cause us to animate our emotions. How good are we at measuring emotions? Quick quiz for you all, keep you all awake. Which is the genuine smile, left or right? Hands up left. Hands up for right. Is your feeling the same now? And what's changed? The eye, that's right. This is one of the challenges in VR. When you look at somebody, most of the information that's important is around the eye region. This is an eye tracking study. You can see this heat map shows mostly time spent looking at the region between the eyes, also around the mouth and speech. What's the problem with VR? Well, this. So we have a problem in VR that you can't measure the facial expressions because the main area for interpreting emotional responses is under cover. We can't use a camera. Computer vision technology doesn't work under cover. And that leads to a number of things, really. I mean, we've seen now there are a number of platforms now for social VR, you can see here. And there's something really wrong with them, isn't it? What's the problem with them? All the avatars are slightly, like my poor patient Bethan, lacking in facial expression, lacking in emotional connection. But we know emotion is important both for entertainment and for gaming and also healthcare. You know, emotion sells. We see an increase in connection, sharing, buying behavior, call for action. So facial expressions enable us to have unique insights in how a person is feeling, what they're going to do, and their subsequent behaviors. My interest in healthcare is around facial expressions for rehabilitation. We have grants to develop a system for improving rehabilitation manifest as a defect in the ability to recognize emotional responses. And also we recognize immediately when someone's in pain from their facial expressions. So I'm going to hand over to Graham, who's going to give us a bit of background further into Emteq.
Thank you. So, Charles set the scene why emotion is important, that facial expression is one of the best and richest sources of information on how we measure human emotion. And it's clear that emotion has a role to play in VR as it does in our real lives. The experience of being in VR without having that full range of human interaction is always going to be slightly lacking. And if you believe, as we do, that VR is fundamentally a social experience and not an isolating experience, then emotion and body language becomes a really important part in the future. And for us, it's one of the key ways to improve the VR experience for all of us going forwards. So, we set out to build a platform that enables emotional interaction in VR and also enables our ability to record emotional responses to VR content, which is really important in a storytelling medium for which the old rules don't apply anymore. 2D tropes that we use in creating films as a matter of course just don't capture people in the same way. The things that draw us in VR content are frequently not the same things that draw us in when we're in 2D, and anybody who has been working in the medium will know that very well. Charles has mentioned that the medical reasons for building the platform are also really important. And he has already mentioned that we're building a version of our platform that helps treat facial palsy. One thing that also has dropped out of that mix is that facial gestures, not emotions per se in its entirety, but the facial gestures we make also give really clear indications about our alertness or fatigue state. And a system that can be miniaturized down into a pair of glasses has really strong utility in driving or flying a plane or being an air traffic controller or any other task that has a lot of attention required for it. So there are many, many uses for this platform that we are in the process of building. So we are building our system initially out into a VR headset, and I'm very excited about our integration with virtual reality and what we can enable in the process in bringing a sense of emotion into that. We are also building our system out into a pair of glasses right now. As you can understand, the miniaturization of that technology means that it's a little bit further away for us. But not only does that give us different utility, but it also gives us a route to access augmented reality and mixed reality as and when it starts to become part of our lives. We're currently building to the Oculus Rift CV1 and the HTC Vive. We're currently focused on the Unity platform as our primary integration, but our system is fundamentally independent of the HMD. We decided that it doesn't make sense to go out and build our own headset. Why would we want to do that? We do want to demonstrate how we can integrate and interact with headsets. So, CV1 is the current platform. This is a mock-up, obviously, but you can see basically we're taking the facial interface out of the HMD. In the CV1 it's a clip, and the HTC Vive it's Velcro. And our system goes in its place, which has facial sensors, so skin contact sensors, which is reading the electrical muscle activity from your face, it's reading your heart rate, it's reading your arousal state, and it's turning that back into useful information using machine learning and artificial intelligence techniques. That's given us a couple of unexpected benefits along the way, like, for example, the ability to uniquely identify you from the electrical muscle activity that your face produces. So here, Mohsen, who is our lead hardware engineer, is pulling an expression whilst gaze focusing on an icon on screen, and the system can identify uniquely from that. Similarly, we can use gesture control because we can recognize your expression. So a wink, for example, becomes an input function, and here Mohsen is just about to do the same function using a wink as an action in order to drive access into one of our demos. And here we just have a very simple demo. This actually is a little while ago when some of the Unity needed cleaning up, but nevertheless you can see the point where just mirroring expression, responding to expression in this. The system as it stands there with the machine learning is recognizing 14 different facial expressions, plus heart rate, and I have to tell you, Mosen's heart rate really is 100 resting. I need to get him some more employee insurance for that one. And here we've got just another version, just another view of you doing the same function. This is using expression gestures in order to drive emojis for likes. What we've built essentially is an open API into Unity. So you plug the system into the inside of the HMD, the Unity API is available to you. What you do with it then is, they're available for the imagination of the user. As I say, the two use cases that we're driving, that we're coming out with for our first production systems are direct emotional translation, so taking your expression and just putting that into Unity so that your avatar is able to express itself directly. And any of you who watched some of Zuckerberg's presentations from Connect 3 back in October may have seen the beta of the Facebook Oculus Social, which is still not out yet, and the avatar expressions that Zuckerberg and the team believe are really important for their market. However, the way that they are activating their expressions in their social beta is using the touch controllers. So you want your avatar to smile, you draw a smile. You want your avatar to frown, you draw a frown. Clearly, they understand the need for that expression. They haven't quite got the mechanism for it yet. Our second use case, as I said, is recording your emotional response annotated against the Unity objects that you're interacting with, so that content creators, market researchers, psychologists, game developers, etc., can look at where the emotional response is actually being received from their target audience, and where actually they're not getting any interaction, the content's leaving them cold, etc. We're Brighton based, we're in the Sussex Innovation Centre. There's currently 7 of us. We're about to go through a major ramp in the first part of next year, which is going to be fun. If you've got any questions, you want to know more, please come and find Charles, myself, or Simon, who's here with us this evening after the presentation. And that's it. Thank you very much.